Traditional AI and generative AI serve distinct purposes in the field of artificial intelligence with unique approaches and capabilities. Understanding their key differences is essential for organizations seeking to leverage AI effectively. Let's unpack the key differences between traditional AI and generative AI. Traditional AI focuses on analyzing data, identifying patterns, and making predictions based on predefined algorithms. It is commonly used for tasks such as classification, regression, and anomaly detection. For example, traditional AI can predict whether an email is spam or legitimate by analyzing specific patterns. On the other hand, generative AI is designed to create new content such as text, images, or code. It learns from existing data to generate outputs that resemble human creativity. For example, generative AI can draft an email or generate an original image based on a text prompt. Traditional AI primarily relies on structured and labeled datasets for its training. These datasets must be prepared and categorized to enable the AI model to perform specific tasks. For example, a traditional AI model used to classify medical images requires labeled datasets with predefined categories. On the other hand, generative AI can utilize both structured and unstructured data. It often leverages unsupervised or semi-supervised learning methods to extract insights and generate outputs. For example, a generative AI model trained on diverse text data can summarize documents or create new content. Traditional AI produces deterministic and task-specific outputs such as classifications or predictions. Its results are focused on solving specific problems with defined outcomes. For example, an AI model can classify transactions as fraudulent or legitimate, whereas generative AI generates probabilistic, creative, and open-ended outputs. It creates entirely new content based on learned patterns, often mimicking human-like creativity. For example, generative AI can create a unique artwork or compose a new melody. Traditional AI is typically limited to specific tasks and operates within the boundaries of its training data and algorithms. Adapting to new tasks or scenarios often requires retraining the model with updated data. For example, a fraud detection model must be retrained to identify emerging attack methods. On the other hand, generative AI is highly adaptable and capable of handling diverse tasks with minimal modifications. It can switch context and applications without requiring significant changes to its underlying structure. For example, a generative AI model can generate both technical documentation and creative marketing content with minimal adjustments. Traditional AI provides linear and transactional interactions. Its responses are predefined and based on program rules. For example, a chatbot powered by traditional AI delivers static answers to frequently asked questions, whereas generative AI enables dynamic and human-like interactions. It understands context and generates personalized, meaningful responses, which makes its interactions more engaging and adaptive. For example, a generative AI-powered chatbot can hold natural, flowing conversations with users. Traditional AI relies heavily on labeled data and requires frequent retraining to improve its accuracy or adapt to new scenarios. Its learning process is specific to the task for which it was trained. For example, a weather prediction model must be updated with new data to improve its accuracy, whereas generative AI leverages unsupervised or semi-supervised learning and allow to derive patterns from data without extensive labeling. It can also be fine-tuned for specific tasks or applications. For example, a generative AI language model can be fine-tuned to create legal documents for a specific industry. Traditional AI is widely used for analytical and operational tasks that require precise predictions or classifications. These include fraud detection, image recognition, and robotic process automation. For example, you can identify fraudulent credit card transactions in real time using traditional AI models. On the other hand, generative AI excels in creative, strategic, and innovative tasks. It is used for content creation, scenario modeling, and simulation of complex systems. For example, generative AI can simulate a cybersecurity threat scenario for training purposes. Traditional AI struggles to adapt to new or unfamiliar scenarios without retraining. It requires updates to its training data and algorithms to remain effective in evolving environments. For example, a customer behavior prediction model must be retrained to account for changing trends. On the other hand, generative AI adapts seamlessly to new contexts by learning from ongoing interactions or minimal fine tuning. Its generalized approach allows it to respond dynamically to evolving requirements. For example, generative AI can adjust its output style to suit different audiences, such as technical professionals or casual readers. In conclusion, generative AI enhances traditional AI by introducing flexibility, creativity, and adaptability, making it a powerful tool for a broader range of applications. This distinction allows organizations to leverage the strength of both AI types for specific needs.